Alright guys, so as you know, we are working on compound probability now. We did some compound trees yesterday. So today we'll actually be kind of diving into what compound probability is, alright? So the probability of two simple events occurring. Okay, so remember last week we did simple probability. So two or more simple events. Okay. Oh, I guess I should have a pen out instead of. All right. So simple. The probability of two simple events occurring. Okay, is compound probability. Multiply the two simple events together. Okay, that's how you get the probability of the multiple events happening. You just multiply each individual simple event together. All right. So for instance, one letter tile out of these ones here. Okay. So one tile is selected and the spinner is spun. What is the probability that both will be a vowel? Okay. Well, first we need to count up how many tiles we have. 1, 2, 3, 4, 5, 6, 7. Okay. So we have 7 tiles. And then what's our probability of selecting a vowel out of there? Well, we have 2 vowels. Okay. So that's how we got 2 over 7. All right. Now when we look at our spinner, how many options are there? Well, there's 6. 1, 2, 3, 4, 5, 6. Okay. And how many vowels are there? 1, 2. Okay. So that's how we got 2, 6, or 1/3. Okay. Then you just multiply them together. Okay. So remember we did multiplying fractions earlier on this year. So we have 2/7 times 1/3. How do we multiply fractions? Straight across, right? So 2 times 1 is 2. 7 times 3 is 21. So we get 2 over 21. So that's our probability of selecting a vowel from both the tiles and the spinner. Okay? So let's go down to the guided practice. One letter tile is selected and the spinner is spun. It sounds very similar to our example up there. What's the probability that both will be a vowel? Well, how many tiles do we have? We have 4 tiles. All right. How many are vowels? Well, A and E are both vowels. So we have 2 out of 4. So 2 out of 4, or 1/2. So we have a 50% chance of grabbing a vowel if we were to just randomly pick a letter. All right. Then we've got our spinner. There's 3 options, A, B, and C. How many are a vowel? 1 of them, just the A. So that means we have a 1/3 chance of spinning for a vowel. Now it's asking, what's the probability that both, okay, what's the probability that both will be a vowel? Well, we've already figured out the simple probability of both of them. Now we just need to multiply them together. So 1/2 times 1/3. Multiplying straight across, we get 1/6. Okay. Number 2, the spinner and number cube. A number cube is the same thing as a die. Okay. The spinner and number cube shown are used in a game. What is the probability of a player not spinning blue? Okay, not spinning blue, and then rolling a 3 or a 4. All right, so what's the chances of, or the probability of not spinning blue? Well, we've got 1, 2, 3, 4, 5 options, and 4 of them are not blue. So for the spinner, we have 4 out of 5 chance or probability. And then the die, or the number cube, okay, is asking us to roll a 3 or a 4. How many numbers are on a number cube? 6. How many of them are a 3 or a 4? Well, 2 of them are, okay? So 2 out of 6, or 1/3, okay? Should probably color coordinate these, make it a little bit easier for you guys to understand. So let's say that the spinner was the blue, and we will make the die purple, okay? And we just said that it was 2 out of 6, or 1/3, okay? Now all we got to do is find the compound probability. So the simple probability of the die, simple probability of the spinner, multiply them together, and we get the compound, okay? So we have 4/5 for the die times, actually, let's not use the x. 4/5 times 1/3, and we multiply straight across. 4 over 15. We can't simplify that, so we have a 4/15 chance. So if we were to do this exact same scenario, spinning and rolling the die 15 times, 4 of them should be not blue and a 3 or a 4, okay? All right, number 3. There are 4 oranges, 7 bananas, and 5 apples in a fruit basket. Ashlyn randomly selected a piece of fruit and replaced it in the basket 50 times. The table below shows the results of each fruit being drawn. Find the experimental probability that an apple will be chosen 2 times in a row. How does that compare to the theoretical probability? So basically, they're asking us to find both the experimental and theoretical probability, okay? So she's done this 50 times, okay? And out of the 50 times, 16 were orange, 19 were banana, and 15 were apple. So let's get, we should probably get the color orange, right? For an orange. So what was our experimental probability of getting an orange? Well, 16 over however many times we did it, 50, which we can simplify to 8 over 25, okay? Banana, our experimental probability was 19 over 50, okay? And we cannot simplify that. All right, and then last one, apple. Let's get a red. And we will say that that was, 15 over 50, which we could simplify by dividing by 5, which would give us 3/10. All right, so there are the experimental probabilities of each of these individually happening, okay? The table below shows the result of the fruit being drawn. Find the experimental probability that an apple will be chosen 2 times in a row, okay? So we want the experimental probability that an apple will be chosen 2 times in a row. Guess what? I just did all that work for nothing because I didn't read very well. All we needed was the apple, the 3/10, okay? So experimental probability that it will be chosen twice in a row, well, chosen once was 3 over 10. chosen again would be another 3 over 10 because she's replacing. So 3/10 times 3/10, and that gives us 9 over 100. Okay. And we cannot simplify that any. All right. How does that compare to the theoretical? Let me write theoretical here. Just like that. Theoretical probability. And go back to the apple. We said there are 5 apples, okay, in the bucket. What's our chance of drawing an apple? Well, how many total pieces of fruit were there? 5 plus 4 is 9, plus 7 more is 16. Is that right? Yeah. Okay, so 5 over 16 is our chance of drawing an apple. Every single time that we draw an apple, we have a 5/16, or I mean, every single time that we draw a fruit, we have a 5/16 chance, okay? But we wanted to know what the chance was of twice in a row, so the theoretical probability of twice in a row is 5/16 times 5/16, and that is 25 over, let's see, 16 times 16 is 256. And let's see, 25 over 256 equals 0.0976. So if we want to change that to a percent, we move the decimal over twice. So we get 9.76%. That's pretty close. We said this one was 9%. 9 over 100 is 9%. Pretty close. All right, guys. Let's see. Let me move this page over. Woof. Everything's still there.